Good day, grade 10 learners. Welcome to a new session of Valenzuela Live in Mathematics 10. I am Mrs. Valerie C. Flaviano from Gente Burcio de Leon National High School, and I will be your teacher for today. Come and join me for another episode of fun learning experience in mathematics. We are now on the third week of the second quarter, which is about relations and theorems on arcs, chords, central angles, and inscribed angles. At the end of this session, you are expected to meet the following most essential learning competencies. Derives inductively the relations among chords, arcs, central angles, and inscribed angles. Prove theorems related to chords, arcs, central angles, and inscribed angles. A circle is a set of coplanar points which is equidistant from a fixed point called the center. Let's have a short recap of different parts of a circle through an activity entitled, Which Part Am I? You will be given 5 seconds to think of the correct answer, then click on the reaction that corresponds to your answer. Are you ready? Let's start. Here is the first figure. What do we call this figure pointed by the cursor? Is it like, radius, part, chord, care, diameter, or wow, secant? You have 5 seconds. Go. Time's up. The correct answer is radius. A radius is a segment joining the center to any point on the circle. In this figure, segment AB is a radius. Let's have the next one. Observe the figure pointed by the cursor. Is it like, radius, part, chord, care, diameter, or wow, secant? You have 5 seconds. Go. Time's up, and the correct answer is chord. A chord is a line segment whose endpoints are on the circle. In this figure, segment CD is a chord. Let's have the next one. Observe the figure pointed by the cursor. Is it like, tangent, part, diameter, care, chord, or wow, secant? You have 5 seconds. Go. Alright, time's up, and the answer is diameter. A diameter is a chord that passes through the center of the circle. In this figure, segment EF is a diameter. Remember that a diameter's length is 2 times the length of a radius. It is also the longest chord in a circle. Also, a diameter divides a circle into 2 semicircles. Let's put a point here, point G. And so we have EGF as our semicircle. For the other side, let's put point H. So we have EHF as our semicircle. So we can say that EGF and EHF are semicircles. Another one, observe the figure pointed by the cursor. Is it like, chord, part, diameter, care, secant, or wow, tangent? You have 5 seconds. Go. Time's up. The correct answer is secant. A secant is a line that intersects a circle in 2 points. In this figure, line IJ is a secant. It intersects our circle in points I and point J. So let's have the next one. Observe the figure pointed by the cursor. Is it like chord, heart, tangent, care, diameter, wow, secant? You have 5 seconds. Go. Time's up. The correct answer is tangent. A tangent is a line that intersects a circle in exactly one point. Look at this figure. In this figure, line KL is a tangent. Also, we have this concept about point of tangency. The point of tangency is the point where the tangent line touches the circle. In this figure, point L is the point of tangency. Let's have the next one. Observe the figure pointed by the cursor. Is it like chord, heart, radii, care, inscribed angle, or wow, central angle? You have 5 seconds. Go. Time's up, and the correct answer is central angle. A central angle is an angle formed by any two radii in a circle. Its vertex is the center of the circle. In this figure, angle MAN is a central angle. Let's have the next one. Observe the figure pointed by the cursor. Is it like major arc, heart, minor arc, care, semicircle, or wow, curve? You have 5 seconds. Go. Time's up, and the correct answer is minor arc. A minor arc is the shorter arc connecting two endpoints on a circle. Here in this figure, we have arc MN as our minor arc. A minor arc is shorter than a semicircle. On the other hand, we also have major arc. A major arc is the longer arc connecting two endpoints on a circle. A major arc is longer than a semicircle. In this figure, arc MON is a major arc. All right, now that we have recalled the parts of a circle, let us now proceed in discussing the central angles, the chords, and their intercepted arc. The measure of a central angle is equal to the measure of its intercepted arc. In this figure, if the measure of angle ABL is equal to 45 degrees, then arc AL is also equal to 45 degrees. Now let's have another example. Given that the measure of angle ABL is equal to 45 degrees, find the measure of the major arc AEL. Remember that there are 360 degrees in a circle, so the sum of the measures of a minor arc and its corresponding major arc will be 360 degrees. Since the measure of arc AL is equal to 45 degrees, then by substituting that, we will have 45 degrees plus the measure of the major arc AEL is equal to 360 degrees. Then by applying the subtraction property of equality, we will have the measure of the major arc AEL is equal to 360 degrees minus 45 degrees. Therefore, the measure of arc AEL is equal to 315 degrees. Another concept is about arc addition postulate. The arc addition postulate states that the measure of the arc formed by two or more non-overlapping arcs is the sum of the measures of these arcs. Let's have an example. If the measure of angle ABL is equal to 45 degrees and the measure of angle LBE is equal to 97 degrees, find the measure of arc AB. Now, we have studied a while ago that the measure of the central angles are equal to the measure of its intersected arc. So therefore, we can say that AL also measures 45 degrees and LE also measures 97 degrees. So we will have the measure of arc AE equals the measure of the arc AL plus the measure of arc LE. Next, by substitution, we will have the measure of arc AE is equal to 45 degrees plus 97 degrees. And the answer is the measure of arc AE is equal to 142 degrees. Now it's your turn. Try to solve this. In circle B, SL is a diameter. If the measure of angle ABL is 45 degrees and the measure of angle LBE is 97 degrees, find the measure of arc SE. Type your answer in the comment section. You will have 30 seconds to answer it. Ready? Go! All right, time's up. And the answer is 38 degrees. Very good. Since SL is a diameter, then it follows that the measure of arc SE plus the measure of arc EL plus the measure of arc LA are all equal to 180 degrees. Now, by substitution, we will have the measure of arc SE plus 97 degrees plus 45 degrees is equal to 180 degrees. Next, we will have the measure of arc SE plus 142 degrees equals 180 degrees. Applying the subtraction property of equality, we will have 180 degrees minus 142 degrees. So therefore, the answer is the measure of arc SE is equal to 38 degrees. Okay? Let us now discuss the theorems on central angles, chords, and their intercepted arcs. Theorem. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Part 1. In a circle or in congruent circles, if two central angles are congruent, then their corresponding minor arcs are congruent. Part 2. In a circle or in congruent circles, if two minor arcs are congruent, then their corresponding central angles are congruent. Let's have an example. In circle A, if angle TAP is congruent with angle MAL, then arc TP is congruent with arc ML. So if the measure of angle TAP is equal to 45 degrees, it follows that arc TP also measures 45 degrees. Also, angle MAL, since they are congruent, also measures 45 degrees. And arc ML also measures 45 degrees. Another example, if circle A is congruent with circle E and angle TAP is congruent with angle KEZ, then arc TP is congruent with arc KZ. So therefore, if angle TAP is equal to 45 degrees, then TP is also 45 degrees. If KEZ is equal to 45 degrees, then the arc KZ is also 45 degrees. Another theorem: in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. In a circle or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. Part 2. In a circle or congruent circles, two chords are congruent if their corresponding minor arcs are congruent. Let's prove the first part of the theorem. In a circle or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. So consider these circles. The given are: circle J is congruent to circle K. Then segment LM or chord LM is congruent with chord NP. We will prove that arc LM is also congruent with arc NP. So we have the statement: circle J is congruent with circle K and chord LM is congruent with chord NP. Our reason is given. Next, JL is congruent with JM, is congruent with KN, and also congruent with KP because they are all radii, and radii of a circle or congruent circles are congruent. Next, therefore, we can say that triangle JLM is congruent with triangle KNP by SSS postulate. Therefore, arc LM is congruent with arc NP. The reason is about definition of congruent arcs. Take note of the following properties of a chord. The first one: the segment from the center perpendicular to a chord bisects the chord. In circle L, if segment LG is perpendicular to segment OM, in this case OM is our chord, then LG bisects our chord OM. Hence, OG or segment OG is congruent with segment GM. The second property: the segment from the center to the midpoint of a chord is perpendicular to the chord. In circle L, if segment LG bisects segment OM, then segment LG is perpendicular to segment OM. Next, the perpendicular bisector of a chord passes through the center of a circle. In circle L, if LG is a perpendicular bisector of chord OM, then segment LG passes through the center of the circle. Let's have the next one. Number 4. If two chords of a circle or of equal circles are equal, then they have the same distance to the center. In circle R, if TY is equal to SL, then they are equidistant to the center. And the next property is: if two chords of a circle or equal circles have the same distance to the center, then they are equal. In circle R, if segment TY and segment SL are equidistant to the center, then TY is equal to SL. Alright, let's have the next theorem. In a circle, a diameter bisects a chord and an arc if and only if it is perpendicular to a chord. Part 1. In a circle, a diameter bisects a chord if it is perpendicular to a chord. Part 2. In a circle, a diameter is perpendicular to a chord if it bisects a chord and an arc. Let's have an example. In a given figure, TY is equal to 10 centimeters and TL is equal to 1 centimeter. If TY is perpendicular to SM and SL is equal to LM, find the length of segment SM. Remember that the length of a diameter is 2 times the length of a radius. Since TY is a diameter, then the radius of the circle is 5 centimeters. Remember that all radii in a circle have the same measure. So the measure of HT, HY, and HM are all equal to 5 centimeters. Now, if we draw a radius from H to M, we will have a right triangle HLM. The radius HM is also the hypotenuse of our right triangle. Notice that HL is equal to HT minus LT. Substituting their values, we will have HL equals 5 minus 1. Therefore, HL is equal to 4. We can now use the Pythagorean theorem in solving for the missing side. LM square is equal to HM square minus HL square. Substituting their values, we will have LM square equals 5 square minus 4 square. So LM square will be equal to 25 minus 16. Then, the answer will be LM square equals 9. We will get the square root of both sides. So the square root of LM square is equal to 3. Note that negative 3 is an extraneous solution since we can't have negative measure of length. That is why we will get the length measure here as 3. Alright, finally, we can solve for the length of SM. Since SL is equal to LM, then SM is equal to twice LM. So it will be 2 times 3 equals 6 centimeters. And that's our final answer. This time, let's talk about the inscribed angles and its intercepted arcs. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. Here in this example, angle ELI is an inscribed angle. Let's proceed to the theorem on inscribed angle and its intercepted arc. Theorem: if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. We will have 3 cases for this theorem. Case 1 is if one side of the angle is a diameter, or the center is on one side of the angle. Case 2, the center of the circle is in the interior of the angle. And then we have case 3, the center of the circle is in the exterior of the angle. Here's an example. If the measure of angle LOT is equal to 32 degrees, find the measure of arc LT. Based on the theorem, the measure of the inscribed angle is equal to half the measure of its intercepted arc. Substituting the value of angle LOT, we will have 32 degrees equals 1/2 the measure of arc LT. Applying the multiplication property of equality, we will have 2 times 32 degrees equals the measure of arc LT. So therefore, the measure of arc LT is equal to 64 degrees. We can also write it in this way. That is applying symmetric property of equality. Here's another example. If the measure of arc EO is equal to 124 degrees, find the measure of angle EXO. Now, based on the theorem, the measure of the inscribed angle is equal to half the measure of its intercepted arc. So substituting the value, of our arc EO, we will have the measure of angle EXO is equal to half 124 degrees. Therefore, the measure of angle EXO is equal to 62 degrees. So now it's your turn. Try to solve this, okay? In circle D, find the measure of angle ANI, given that the measure of angle ADI is equal to 148 degrees. Type your answer in the comment section. You have 30 seconds. Go! Time's up! The answer is 74 degrees. Very good. Note that the measure of the inscribed angle is half the measure of the central angle subtended by the same arc. So, the measure of angle ANI is equal to half the measure of angle ADI. Substituting the value, we will have the measure of angle ANI is equal to 1/2 148 degrees. Therefore, the measure of angle ANI is equal to 74 degrees. Here's another concept. An inscribed polygon is a polygon whose all vertices are on the circle. The circle is said to be circumscribed about the polygon. Here, STAR is an inscribed quadrilateral. The opposite angles of inscribed quadrilateral are supplementary. Angle TSR and angle RAT and angle ATS and angle SRA are opposite angles of inscribed quadrilateral STAR. Hence, we can say that the measure of angle TSR plus the measure of angle RAT is equal to 180 degrees. And the measure of angle ATS plus the measure of angle SRA is equal to 180 degrees. Okay? Another concept that we will discuss is about the angles formed by two intersecting chords. If two chords intersect inside a circle, then the measure of the angle formed is 1/2 the sum of the measures of the arcs intersected by the angle and its vertical angle. The two chords TR and HE intersects inside circle A. The measure of angle 3 is equal to 1/2 the sum of the measures of TH and arc R. Now let us go deeper with this topic. Okay, let's draw angle 1. So, the measure of angle 1, that is RTE, is equal to 1/2 the measure of arc ER, based on the inscribed angle definition. And as well as the measure of angle 2 is equal to 1/2 the measure of arc TH. The measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2, for the reason that an exterior angle of a triangle, in this case that's angle 3, is equal to the sum of its two opposite non-adjacent interior angles. In this case, angles 1 and 2. By substitution, the measure of angle 3 is now equal to 1/2 the arc ER plus 1/2 the measure of arc TH. Therefore, we can say that if two chords intersect inside a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intersected by the angle and its vertical angle. So let's have an example. In circle E, find the measure of arc RW. If the measure of angle RLW is equal to 127 degrees and the measure of arc FO is equal to 61 degrees. So here's the measure, okay? The measure of angle RLW is equal to 1/2 the measure of arc FO plus the measure of arc RW. Substituting the values, we will have 127 degrees equals 1/2 times 61 degrees plus the measure of arc RW. Applying the multiplication property of equality, we will have 2 times 127 degrees equals 61 degrees plus the measure of arc RW. Okay, and that's 254 degrees. Next, we are going to apply the subtraction property of equality. So we will have 254 degrees minus 61 degrees equals the measure of arc RW. Therefore, the measure of arc RW is equal to 193 degrees. Okay, now it's your turn. Try to solve this. In circle U, find the measure of angle PLO, given that the measure of arc PO is equal to 79 degrees and the measure of arc SD is equal to 61 degrees. Type your answer in the comment section. You have 30 seconds. Go! Time is up, and the answer is 70 degrees. Very good. Now here's the solution. The measure of angle PLO is equal to half the measure of PO plus arc ST. Okay? So substituting the values, we will have the measure of angle PLO is equal to 1/2 times 79 degrees plus 61 degrees. And we will have 1/2 times 140 degrees. Therefore, the answer is the measure of angle PLO is equal to 70 degrees. Alright, to wrap up our discussion, here are some important things to remember. If two central angles are congruent, then their corresponding arcs are congruent. If two arcs are congruent, then their corresponding central angles are also congruent. Next, if two central angles are congruent, then their corresponding chords are congruent. If two chords are congruent, then their corresponding arcs are congruent. And of course, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. That's it for your weekly home learning task. Answer what's more and what I can do part of lesson number 3, found on your module. It is the activity flashed on the screen. Let us now talk about the frequently asked questions regarding our topic. What is the measure of the inscribed angle that intercepts a semicircle? The measure of the inscribed angle that intercepts a semicircle is 90 degrees. Next, what is the measure of an inscribed angle whose intercepted arc is the same with the intercepted arc of a central angle? The answer to that question is the measure of the inscribed angle is half the measure of the central angle subtended by the same arc. Thank you very much, grade 10 learners, for actively participating in our discussion. Stay safe and God bless.